Good afternoon and welcome to this week's IGC Events webinar Focus on Geothermal, which is presented by ThinkGeoEnergy and Enerchange. My name is Jochen Schneider and today I'm pleased to welcome Giulia Filippini and Paolo Danesi from Exergy International. They will talk about the continuous growth of the ORC technology. Paolo Danesi studied chemical engineering and has extensive experience in business development and sales on the international market in various fields. Since 2023, Paolo has been responsible for sales activities with offices and teams located in Italy, Turkey, and Malaysia. Giulia Filippini has a solid background in energy engineering and refined her expertise in field service activities. She is a commissioning and service engineer and developed thereby a huge knowledge of ORC plants, which helps her in her daily work. In their presentation, they will give insights into the driving factors and benefits of the expansion of ORC technology. They will briefly discuss the innovative features of Exergy's ORC technology, especially on the radial outflow turbine. They will show examples worldwide. We are looking forward to an interesting presentation. Giulio, Paolo, the floor is yours.
Very good afternoon, ladies and gentlemen. This is Paolo Danesi, Director of Sales at Exergy. I will start with the presentation, and then I will hand over this to Giulia. I will start with a general presentation of the market trend about ORC, why ORC is having this good result in terms of market. The ORC technology, which is of course not is an old technology, I would say, but has been used extensively in the geothermal application in the last 2 decades. And there is the trend that we see in the market is that this technology is preferred to the flash steam or dry steam. They also call like a binary technology. In fact, in the period between 2015 and 2021, the new capacity installed with ORC registered a big growth of 13%, with almost 1900 megawatt installed against 1300 megawatt for flash and some small amount for dry steam. And this is only in the last 6 years. In the last 2 years, we noticed that there are at least additional 40 binary, so ORC power plants that has been installed in this period against 9 single flash installation. This means that the market is looking at ORC as the real technology for the geothermal application, especially when, of course, we are looking at the low enthalpy geothermal application. Well, we expect that this positive trend is going to continue for the next decade. That's why we at Exergy are very excited about this moment in the market, with the expectation of ORC installation to grow at 12.8% growth in the period between 2023 and 2032. We expect, according to some estimation, that the installed capacity for ORC will reach 11 gigawatt by 2032. As you can see, from the installed capacity around the world seems to be more or less the same. The growth will be more or less the same in all the regions, as this technology is now extensively used everywhere in the world. Well, what is the driving for this growth? The large potential low and medium enthalpy resource available and unexploited that cannot be harnessed with flash steam or dry steam is for sure the best fit for ORC. So whenever there is leftovers, let me use this word, from the classic geothermal application, there is a space for ORC, and the need for the owners and developers to exploit as much as possible the enthalpy in the fields already existing is driving this need. Of course, the interesting part of this, let's say, this segment of application is the fact that in this way we are minimizing the drilling cost. So there's no drilling cost when you associate the exploitation of existing wells with ORC. But even in new wells, in new geothermal application, we see more and more the use of ORC, given the proven flexibility that this technology has been providing in diverse geothermal resources. So for sure in the low enthalpy application, but also in the medium enthalpy application, has been replacing or combining with the old traditional steam turbine application. For example, in our power plant of Baguio in the Philippines, the temperature of the resource that we were using is around 200 degrees. The ORC is very flexible because can be used mixing different resource conditions, so steam, brine, or mixed steam and brine resource. And so, of course, this allows a big flexibility in the plant operation. Of course, the ORC should not be seen only as the only technology, but can also be seen as a good complement even in new plant, in combined cycle with a flash plant. So this will increase the efficiency of new wells. This technology is also the preferred technology for the production of power in AGS, enhanced geothermal system, where typically the resource is at a liquid state. These technologies can also be used in plants where the extraction of lithium is another driving of the project. Sorry for skipping. Where the extraction of lithium is another driving of another driver of the projects, and so this technology is pretty well combined with a new trend in the energy transition market. So the extraction of lithium, which is becoming a key issue around the world. And then, of course, it's important to mention that the ORC technology can work in a closed loop, in total closed loop. So with a total reinjection of condensable gas in the reservoir, so avoiding any emission in the atmosphere, which is very important in many countries, and it's also, let's say, supported by the legislation in many countries. Also, we need to mention the fact that there's no water consumption due to the use of air-cooled condenser, and the impact in terms of visual impact in the landscape is limited compared to the steam plant. Markets in ORC, as we said before, are basically everywhere, are following the new trends of the geothermal application around the world. We see big trends in US. US is growing again with, especially with enhanced geothermal systems, with the new projects coming out supported by the local policies and of the member states, with the IRA and other incentives. And we see a lot of growing interest from big corporations, even in the IT, let's say, business, entering into the investing in the geothermal, which means looking at geothermal as a real source of 24/7 available and source of energy, and green source of energy. So US for sure will be an important market in the future for this technology. Africa itself, provided we are able to support financially the country, and this is happening also from Italy, there are huge potential for the for geothermal application, and in particular for ORC, where this technology could be used to exploit up to the last bottom the already existing plant, for example, in Kenya, where there are already flash plants, and we can use the last enthalpy with the ORC. Europe is, of course, one of the most important markets. We are looking at Italy, of course, as an Italian company. There will be hopefully a new push from the new government, from the new law legislation in Italy about geothermal with a FAIR 2, where there are at least 80 geothermal projects under development for around 1 gigawatt, and all of them, most of them will be, I would say, the biggest part of it will be using ORC. In the rest of the world, the trend will be followed, with Asia Pacific being an important area where there will be a lot of resource to be exploited, and so the decarbonization of those countries will also be helped by the installation of geothermal plant and ORC in particular. A quick look of our features of Exergy's technology that allowed us to have to build in less than 15 years almost 500 megawatt of installed power. Our technology is featuring a radial flow of the fluid, of the organic fluid, through the section of the disc, which can be put in a stage, in several stages on the same disc, to increase the isentropic efficiency of the system, of the turbine, and have a better off-design performance. This allows better performance in terms of noise and vibration, and increase the possibility and the opportunity to have a improvement in the maintenance. And Giulia will give you some details about this. I will speak about a project we are executing now, United Down geothermal project. We are executing in UK, in Cornwall, where this is a typical example of one of the first example of an ENSE geothermal system with of 3 megawatt, with one production well of 5,000 meters approximately, and one injection well of almost 2,400 meters. This technology is allowing the possibility to recover heat from the rocks, from the hot rocks in the bottom of the earth, and will allow also the possibility to recover lithium in this plant. This system will be for sure widely used in the market, in the future market, especially in the US and Europe, and will increase the possibility to have geothermal projects around the world at a reasonable price. This is a layout of the plant, 3D layout of the plant, with some features. It's a 3 megawatt plant with a gross efficiency of 17.1%. We are executing this job in the fuel EPC scope, and we expect to start up the plant in 2024. The flow of geothermal brine is around 40 liters per second, and the temperature of the resource is 175 Celsius degrees, with a reinjection temperature of 50 degrees, around 50 degrees. Is an air-cooled condensed plant, so able to be very flexible and very efficient. I leave the space to Giulia.
I will. Thank you, Paolo. I'm Giulia Filippini from Exergy. I will continue through this, the discussion of case study. Another interesting example of geothermal installation is the brine recovery project that is currently under construction and is going to be started up at the end of this year. It is located in the geothermal site of Mahanandong in the Philippines, and here there is an already existing flash sim power cycle that is running since around 2 decades, and recently our customer Energy Development Corporation, the Philippine company that operates Mahanandong facility, has decided to invest in the further development of this plant with the installation of an additional capacity of around 28 megawatts. So far, previously, the return brine flow from the steam cycle was wasted. Namely, it was directly reinjected in the well, in the geothermal well. While now, thanks to this ORC project that is going, that will be started very soon, the plant facility will have an additional, will increase its efficiency. In this project, it's worth to mention that the brine composition was quite challenging for its chemical properties. In fact, especially due to the high silica content of this brine, it would be practically impossible to use the brine as it is and cool it down from 180 degrees to 80 degrees through the ORC. So we developed a customized system for acid dosing that consists of injection of highly concentrated sulfuric acid in the brine flow, and together with the monitoring of the brine pH downstream the ORC, it allows the careful control of silica saturation point, and it allows the operation of the ORC cycle smoothly without silica deposition issues in the heat exchanger and the brine pipelines that would be detrimental for the performance. So this is an interesting case study for this particular acid dosing system. That is key for the performance of the plant. One further case study that I want to tell you about is the geothermal plant of Accra. Here it is. You can see it in the picture. The start of operation of this plant dates back to 2015, and it's worth to mention it because it represents a particular case for the plant layout configuration. In fact, in this combined steam brine geothermal ORC, the design was studied in order to develop a two-pressure cycle ORC plant, which means that there are two evaporation stages at different pressure, and this allows to deliver, and this allows to maximize the thermodynamic efficiency with minimizing the irreversibility. So this guarantees the maximum thermal recovery of the heat resource. On the other side, the peculiarity of these plants is that the two pressure cycles are conveyed to the same and expanded in the same turbine. So the high pressure cycle enters from the main turbine entrance, and the low pressure cycle, the low pressure flow enters at the later stages. But they are combined on the same machine, which allows, of course, a significant cost reduction for this plant compared to an equivalent solution with the two machines. And this solution with the two pressure level on the on a single turbine disc is can be uniquely developed with the radial outflow turbines, because it is much more compact, and the radial entrance and the radial configuration allows the access of multiple flows, while on the axial turbine the double entrance would have given complications in terms of mechanical stability of the machinery. So this is an interesting case study. Now, taking coming from the field experience of these and other projects that were developed in the geothermal field, I want to talk in the second part of this webinar. I want to talk about the maintenance and operational aspects that are characteristic of the ORC plants. And this is probably a topic that is not very often dealt with. I hope you will appreciate this part. So before diving into the specific of maintenance in the ORC, I'll recall a couple of key differences that distinguish the binary ORC plants from the steam cycle. The first difference is related to the chemistry of the working fluid. So while in the steam cycle we have water, which means that we have oxygen content in the plant, and this oxygen brings with it a series of risk related to the risk of the problem of corrosion and rust formation. So in steam cycle, for the operation, it is essential to have in mind some chemical treatment and which are specific practices that are inevitable to guarantee the oxidation protection of the internal surfaces of the plants. While in the case of ORC plant, the working fluid is, from the chemical point of view, belongs to the family of solvents. So there is no oxygen, and it is a closed loop. And so in the internal piping and equipment of the plant, there is no issue of corrosion. The other key difference between steam cycle and ORC is related to the thermodynamic of the turbine, of the expansion of the working fluid in the turbine. So while in the steam cycle, the water during the expansion, goes in the two-phase region. So it means that there is the formation of liquid droplets in the turbine, which impact on the turbine blades, causing erosion, and therefore the performance gets worsened along the plant operation because of the erosion of turbine blades. And for this reason, steam cycle generally require a periodic maintenance, consisting in the opening of turbine and refurbishment of the turbine blades. That is essential to keep the performances. On the other side, in the ORC plants, the organic fluid expands fully in the vapor region, so there is no matter for the blades at all, which has the key consequence of making the maintenance of these plants much easier. There is no performance degradation, no invasive maintenance on the turbine. Okay, this is to have an overview and to say that the ORC plant maintenance is much more easier. However, there are some few maintenance pillars that should be followed. In order to keep a high plant reliability. First is the planning of machines overall, according to the specific maintenance timing for the equipment. Second, performing predictive maintenance on the most vulnerable components, mainly the mechanical components that are subject to wear. And third is the stock of critical spare parts. In this case, I refer mainly to the plant components related to instrumentation and plant control, the PLC, and especially the some electric and electronic components that, for sure, in the recent years are more and more reliable. But on the other hand, their supply chain may experience once in a while some shortfalls due to the difficult procurement of some specific material for these electronic spare parts. So it's fundamental to have them readily in stock in case of for ready replacement in case of unexpected failure. Then I want to give an overview of the main appointments of the maintenance along the plant lifetime. The plant is designed for more than 25 years, and starting from the mechanical equipment, the feed pumps only basically need the replacement of mechanical seal and bearings, which are the wear parts, and after 5 years, and an additional check of the internals after 10th year. The same, more or less, is for the generator, which doesn't need much maintenance, and the big refurbishment is only after 10 years, with the check of the electrical windings and replacement of bearings, sleeve bearings. Then we have the turbine, where the wear parts are concentrated in the mechanical group, which is the core for the transmission of torque through the shaft. And we have seen that the blades are not impacted. So the opening of turbine is only suggested after 10 years for the check of the internals. Then about the mechanical group, we are going to see soon an insight about this replacement activity. Then about the rest of the plant, we have the control valves and the piping, which requires the replacement of the gaskets and for the piping, and the internal seal for the valve body and their actuators. About heat exchangers, it's worth to mention that the heat exchangers are what determines mainly the stoppage for maintenance of the plants, and they require maintenance, which is essentially cleaning of the tube sides of the shell and tube heat exchangers. and the cleaning is necessary on the hot source, depending, and the frequency may depend on the brine composition, on the heat source composition. Then we have, of course, the maintenance on the safety valves, whose inspection is required with different frequency according to regulatory rule frame of the specific installation site. And all these maintenance agenda should include the standard annual maintenance program. Now we'll focus on the turbine maintenance, on the maintenance of the with the replacement of mechanical group of the turbine. And with a focus on the radial outflow turbine, which is a patented technology and finds the largest number of applications right in the geothermal binary cycles field. In this case, this turbine is designed to have the wear parts, the bearings, and the mechanical group and the mechanical seal in this kind of cartridge, which is the mechanical group, and this holds the rotor. And with and moving the rotor toward the turbine case, the plant is sealed, so there is no need of draining the fluid of the plant and refilling it at the end of this operation, with a lot of time saving in terms of maintenance. And this mechanical group cartridge can be extracted, and the new one can put back in with the whole operation to be completed in between 1 and 2 days. And thanks to this, to the application of these good practices for the operation and maintenance, we're proud to show that the ORC installations are a valid solution and reliable solution, and can guarantee very high number of availability, nearly 99%. These are yearly data of availability of some of the geothermal plants in our portfolio. So this is again the confirmation that is a mature technology. So to wrap up, the ORC, we can say that the ORC are a growing and more interesting solution thanks to these main features: the high thermodynamic efficiency for exploitation of medium-low temperature heat resources, and the easy maintenance, which allows a high reliability of these plants, and the closed loop cycle, which gives a low environmental impact, which is a very interesting point.
Yeah, I think that we showed all our slides, and I hope we gave them all the right messages.
Okay, then thank you very much for your presentation. Could you please move to the next slide, where we introduce the IGC? Exactly, I want to here also announce the IGC, Geothermal Finance and Investment Forum in Frankfurt, June 25-26, which is organized by Enerchange. Here we have an interesting program of local utilities searching for investors, investors for projects, and also we will focus on the EU taxonomy with presentations from the EU, from the KfW, and also from Hogan Lovells, who is here our top sponsor, who will also host the event in the 35th and 44th floor in Frankfurt. And a very interesting session is about risk mitigation. Here we will introduce risk mitigation schemes for France, for Switzerland, and also for Germany, what is in development. But now we continue here with the questions. We already have plenty of them, and I will go through them. We still have time till 3 o'clock and hope to manage so many questions as possible. The first one, according to scaling deposit prevention, what kind of maintenance program that you implement on the various sites? Any specific treatment for every site? Please advise.
Okay, thank you for the question. I will answer. So to prevent the scaling deposit on the brine side, the main action is to analyze the brine composition, and according to the brine composition, develop a system that changes, basically it changes the pH and the saturation conditions of this silica, and because the scaling is mainly related to silica content in the brine side, and changing the saturation conditions of this silica allows less scaling. About the prevention, then about the maintenance actions. The maintenance mainly consists of cleaning the heat exchangers tubes, because the heat exchangers between the heat source and ORC are usually shell and tubes type, and so the action is cleaning the internal of the tubes with the mechanical action or chemical action.
Okay, thanks. Here is another question related. Could you please explain with more details about heat exchanger cleaning requirements? Is it only a scaling issue?
Yes. Basically, it is scaling and the deposit of a kind of fouling, and this fouling gradually degrades the heat exchanger performance. So among the maintenance, the operation of the plant, one of the activity is to monitor the heat exchanger parameters, so the temperatures, the pressures, and through the monitoring of the trends of these parameters, we are able to determine what is the degradation rate of the heat transfer, and therefore we are able to advise to our customers when it is suggested to clean the heat exchangers in order to keep a high performance of the plants.
Okay, thanks. The next question, what working fluids are selected for ORC? What are the considerations?
Well,
sorry, can you repeat the fluids?
The working fluids
okay.
in the second cycle.
Yeah. Yes, the working fluids can be basically are grouped into family. One is the family of refrigerant, which is the same the same type of fluid that is used for refrigerator, but in this case they are used as working fluid of the plants. They have the advantage of being of not being flammable, not being flammable. So there is no, if the customer has concerns about the ATEX, the hydrocarbons. This is the preferred choice, the refrigerant fluids. On the other side, there are hydrocarbons that can be used. Hydrocarbons generally can be cyclopentane, isopentane, butane, and normal butane or isobutane. And basically, according to the temperatures of the heat source, the fluid is chosen in order to maximize the efficiency of the plant. So according to the temperature range, basically one fluid rather than the other is selected.
Could you say something about the global warming potential of the refrigerants versus the hydrocarbons?
Yeah. In fact, I didn't mention about it, but the refrigerant, of course, have bring with them some concerns about global warming. For this reason, some of them actually have been banned. For instance, in the European community. One of them is the so-called R245FA. This fluid used to be used and now is banned in Italy and in Europe because it has a high ozone depletion potential, so it's very harmful for the global warming issues. However, an alternative of this refrigerant fluid, an alternative has been developed in the field of refrigerant. It is another fluid. If you want to search more, is the name is commercial name is R123ZE, and this fluid has instead similar properties from the thermodynamic point of view, but a much lower ozone depletion potential. And in any case, and generally, this fluid, the working fluid in our plants is working in a closed loop, so there is no impact on the environmental point of view, because basically the same quantity that is installed is lasting for the plant life. It's usually it's required a small percentage points integration.
So you need no refill of the working fluid during the life plant.
Yeah, basically the closed loop ensures that the fluid doesn't need refill. A minimum amount of fluid may be lost due to some maintenance operations. For instance, in the case of cleaning the filters, the mechanical filters at the inlet of suction of heat pump, in that case, inevitably there is the necessity to open the filter. Then we have a very minor amount of fluid that is lost, because of course the procedure tend to minimize this loss, but it is really few percentages points of the total fluid amount along the lifetime of the plant.
Okay, thanks. Are there any economic considerations when selecting working fluids, refrigerants versus hydrocarbon?
Well, I can tell that, of course, refrigerants are much more expensive, very much more expensive than than hydrocarbons. There is a huge difference, and of course, this is one of the key driver of the selection. Not the only one, but one of the drivers.
So what is in the majority of your plants contained, refrigerants or hydrocarbons?
Hydrocarbons are mostly used in the geothermal application.
Okay, thanks. Why was the plant in Turkey chosen with 1 turbine and 2 cycles instead of 2 turbines?
The actual plant, the main point is that the configuration with 2 pressure flows going in the same turbine has the advantage of having 1 single turbine machine instead of 2, so it has a significant cost reduction and also reduction of the on the size of the foundations. It is a very compact machine, and it is allowed by the radial outflow configuration. It wouldn't be possible with other kind of turbines.
Okay, here another question. What about ORC maintenance schedule? How many spare parts that we must keep as stock? Could we conduct project management regularly by ourselves, or do we have to invite the Exergy regularly?
Basically, as Exergy, we recommend an initial stock of spare parts, and because it's good to have these spare parts in order to have prompt intervention. And from Exergy side, from Exergy side, this is our suggestion. Then we are directly involved in supporting our customers during the maintenance with the replacement of spare parts, and especially to perform the maintenance on our turbine. So the special support that we give to our customers is the replacement of the mechanical group.
Okay, thanks. In Middle Europe, the heat transition is moving forward in the center of the discussion of the use of utilization. What about the combination of power and heat utilization?
I can answer to this, and I just I think it's something that is a trend that we're seeing very more and more. Well, typical use of geothermal application was the greenhouse, for example. In Iceland, you still can see a lot of greenhouses that are fed by geothermal. The geothermal, as combined with the power generation, is becoming very interesting in many countries. In Germany, German utilities are looking at this kind of application. Of course, there is, let's say, a technical challenge, which is the possibility to have seasonality, so fluctuation in the load, and so in the different plant utilization between summer and winter, because of the different need of heat between summer and winter. But it's interesting to see how geothermal power plants are becoming kind of a combined heat and power that will need more and more flexibility. We are studying some of these applications.
Another question is, how is the price development of ORC? We see an increase for the drilling costs, especially here in Germany, a significant increase, as there is also a high demand on steel on the worldwide market. What about for ORC plants? How well? What is the price development in the last 10-20 years?
Well, the price development, the development of the price and cost of ORC is more or less the same in all the electromechanical industry. Of course, the last 3 years were an up and down, and there was a big increase, of course, during the start of the Ukraine war. Now we see more or less stabilization of this, even though some manpower linked cost, like electronic components and engineering and also construction costs, are still growing because of the inflation. But overall, we see, let's say, a stabilization of the growth, which was totally
it's a stabilization on high level, or was the price dropping again after the Ukraine crisis?
No, we didn't see a drop, or we didn't experience a return to the past.
What effects is this on the economic side of electricity production?
Well,
just going back to Germany, we have a feed-in tariff of 250 euro per megawatt hour.
Well, of course, this has an impact in the price and the levelized cost of energy, for sure. But of course, as I think you said, that the cost of drilling is another big component of the cost of geothermal. So I would say that the increase of cost of ORC, I don't think will determine, let's say, a big killing point for the development of geothermal ORC in the geothermal application. I think that
no, I don't mean that the ORC price itself, but the general cost, the rise of the drilling cost together with the rise of the ORC cost. We have higher costs. However, the feed-in tariff did not rise.
Yeah, this is of course it's let's say limiting the profitability of some plant, and let's say making more difficult the life of development of developers. So developers are for sure more careful. We also have to remember that on top of the cost, increased cost of equipment, there was an increase of cost of money for the new interest rate, which was probably even more detrimental to the development of plants, more than the cost of investment. Of course, the lifetime of these plants are very long. Okay, the feed-in tariff have a limited life, but once the plant is paid out, the lifetime of this plant is quite long. So the real issues, I think, we perceive with some customers is the cost of money, so the interest rate related to the financing of this project.
Okay, thanks. Are there any plans to combine the plants with lithium extraction?
Yeah, as I mentioned in my presentation, maybe I was not so clear that, for example, our project in United Down in United Kingdom, so the gel project for in Cornwall is going to produce lithium. I think it's 100 tons per year of lithium, the carbonate lithium that will be produced. And I know about many other projects also here in Italy who are considering the possibility to extract lithium. This for sure will be a trend, because the combination of ORC and lithium extraction with modern technology like electrochemical technologies will be for sure a trend in this transition.
Okay, thanks. Here a technical question. How many radial discs could be feasible to approach higher isentropic
we only have
effects?
typically only one disk that can fit up to 7 stages plus 2. So each disk can fit at least 9 stages up to the present technology development.
Okay, so thanks. Yeah.
Please.
The next question, what is the typical execution time from conceptualization to operation for both geothermal and industrial waste?
Well, concept
waste
of a plant
recovery installations.
You mean from the very beginning of the let's say geothermal plant, from drilling or from the moment you sign
drilling, I assume.
Well, this of course depends much on the country, on the resource, on the client, but
possibly the realization of the power plant.
Well, let's say that the realization of the power plant from the contract signature varies between 20 to 24 months, depends on size, maybe even less sometimes if construction activities are not so complicated and logistics is not so complicated. So I would say between 20 to 24 in medium size application. They can be also smaller. I mean, quite quicker with a modularized plant, standardized plant that are allowing the reduction of engineering period.
Okay, thanks. What is the typical payback period?
Well, this depends a lot on the feed-in tariff, so it's difficult to answer.
What we discussed before. Then here we have a last question. Are also up to 5-year maintenance contracts at Exergy?
Giulia, I leave it to you.
Yes, there are. We have our clients service maintenance contracts that are from 2 to 5 and up to 10 years period. What was the question?
Yes.
Okay.
Yes. Okay, thank you very much for the presentation, for the lot of answers to the questions. Thanks also to the audience for the questions. And looking forward to see you soon. Please also don't forget to check out the IGC Invest Geothermal Conference. The website is www.investgeothermal.com. And I wish you all a very nice weekend and hope to see you soon here. Bye-bye.
Thank you very much.
Thank you all for giving us this opportunity.